In these examples, the subject is obtaining the limit by simplifying. That always happen when you get when you try to evaluate the limit and then you get a 0 over 0. So let's do example 1. So for example 1, if we plug, the first thing we always do is plug the x value, plug the 3. So if we plug 3, we get a number, we're done. If not, then we have to somehow factor and simplify if we get a 0 over 0. So let's plug 3. If we plug 3, we'll get 4 times 3 minus 12 over 3 minus 3, and this is 0 over 0. Now every time we get a 0 over 0, all you need to do is factor, simplify, and then plug in your x value. So let's do it. So limit of 4x minus 12 over x minus 3 as x approach 3 is equal. So all we need to do, factor the top. If you factor, we can factor 4. So factor 4, you get 4 factors of x minus 3 over x minus 3. Of course, this is a limit as x approach 3. Now simplify, and then you get 4. So this is your limit. For the second example, if we plug a negative 1, we'll get negative 1 squared plus 4 times 1 plus 3 over negative 1 squared minus negative 1 minus 2. And just verify that's a 0 over 0. So same thing, we need to somehow factor and simplify. So let's call this 2. 2 is the limit we're looking for. So 2 is the limit as x approach negative 1 of, if we factor the top, we're looking for factors of 3. When you add them is 4. So it's plus 1 plus 3 plus 1 plus 3. Now for the denominator, we're looking for factors of negative 2. When you add them, you get negative 1. So negative 2 and plus 1. So x plus 1, x minus 2. So same thing, simplify x plus 1. This will be equal limit of x plus 3 over x minus 2 as x approach negative 1. Now just plug it in. Plug in negative 1. So negative 1 plus 3 over negative 1 minus 2. 3 minus 1 is 2. 2 over negative 3. So it's a negative 2 over 3. 2 over negative 3. Yep. Now for example 3, same thing. If we plug a 5, suppose you get 5 squared minus 9 times 5 minus 5 over 5 squared minus 25, and you check that out, you're going to get 0 over 0. So therefore, we have to factor and simplify. So 3 is equal limit as x approach 5. Now we need, when we have a problem like this, there's a trick here. I mean, you still have to factor, but there's a shortcut. The denominator is easy to factor. That's just x minus 5 and x plus 5, right? Now we need to factor the top, and it's not quick to factor. I mean, you can't do it that quick. So these like a shortcut. What you do, you know, if you plug x equal 5 in the denominator, this is the factor that gives you 0. So we know the top one, we will have x minus 5. So it's x minus 5, and then you need to figure out what are these numbers. Now I know that x times this number should give me 2x squared, so I know this is 2x. And then I know this number times negative 5 should give me minus 5. So this has to be plus 1. So it's a tricky one, and you can FOIL it just to check. But if you know how to factor, do it. This is just a shortcut. Now here I'm going to simplify x minus 5. So this is a limit of 2x plus 1 over x plus 5 as x approach 5. Now just plug it in. So 2 times plug 5 for x, 2 times 5 plus 1 over 5 plus 5, and that's 10 plus 1, 11 over 10, and this is your limit. That's pretty easy. So that's it for these examples.